At the Biodesign Institute, when we look at the future, what do we see? Is the convenience of our lifestyle contaminating our water? That's what Rolf Halden and his team are investigating.
We are studying the movement and fate of chemicals in the environment and how they get into people and what the effects are. A lot of us buy antimicrobial products. Why? Because that's the first stuff we grab when we reach into the shelves of supermarkets. You can detect triclosan in 99% of breast milk samples from US women. If that message would get out, people wouldn't buy all these products.
What if we could clean wastewater and produce energy at the same time? That's what a startup from ASU called ArbSource discovered.
We'll be adding so much value to the way that water is managed, in the way that waste is converted from what is right now just a costly liability into a valuable resource. The best part about having the Biodesign Institute as a strategic partner is that they bring world-class expertise to our scaling efforts.
Could we harness the Salmonella bacterium, grow it in space, and use it to fight disease? Cheryl Nickerson's work focuses on this intriguing possibility.
What we do with bacteria in space is try to use the microgravity environment of spaceflight to unveil novel clues. Our experiment flew with the Salmonella, so genes were being turned on and off differently than when we grow that bacteria on the ground, because the force of gravity can actually mask certain key cellular responses. Coming here to the Biodesign Institute has been a wonderful opportunity to work with the leading researchers in the field in a very multidisciplinary approach.
Can we detect disease by looking at our body's natural responses? Stephen Johnston harnesses this technique known as immunosignaturing for his work.
It's a way that healthy people can simply monitor their health on a regular basis. The B cells in your body that make the antibodies are just like little sensor bodies. And as soon as they see something aberrant, they react to it. So that's why we can see very early disease indications. The immunosignaturing technology is very broad technology. It can be applied to essentially any aspect of health. And we think that that will fundamentally turn around diagnostics.
Hao Yan enjoys doing origami with strands of DNA, finding entirely new applications both for biomedicine and nanotechnology.
We like to extract the design rules from nature. The DNA origami is a way to fold DNA molecules into designed molecular architectures at nanometer scale. What we can learn from nature is to create molecular assembly that can mimic nature's complexity, and also to develop programmed drug delivery that can be used to kill cancer in the future.
What if we could sequence the entire genome of a single individual for less than $1,000? Stuart Lindsay utilizes nanotechnology to achieve this revolutionary aim.
The nanopore is a tiny hole, little wider than the size across a DNA molecule. So DNA is forced to feed through it like a snake, where some technology can be used to read it. In some senses, like the famous Star Trek tricorder, scan it in front of a person and back comes a full report. And so this is going to be a sort of super tricorder, able to extract molecular information unique to every individual.
What do we see when we look into the future? We see sustainability, energy, vaccines, health, nanotechnology, and treatment. The Biodesign Institute, improving health, protecting lives, and sustaining the planet, celebrating 10 years of discovery.